Hello guys, I hope everybody is able to hear me out. So today's session we will start. Okay, before we start, please go ahead and hit like. Yes, I'll talk about distributions also. Don't worry. Okay, so just a quick announcement, everyone. Today is the last day of start session, and probably let's see in the future again. I may plan, but next week, probably on Monday, if everything goes on fine, I'll also start machine learning. The machine learning algorithms part. Understand in this 7 day session of machine learning, I'll discuss about all the machine learning algorithms. Probably I cannot include practicals. See, practicals are already there in my YouTube channel. The reason why I'm not saying, why I'm not planning to include, because see, it will take time to cover up, so I don't want to take one session to 2 to 3 hours and probably do it. Okay, so Aditya, I think the status is already replied. Like every 24 hours, you get the status with respect to one neuron. Now, just a quick announcement. As I said, mostly from Monday. I don't know whether I'll be starting on Monday or not, but I'll make a sure announcement of that. We will be covering up all the machine learning algorithms. That is what we are going to do. Okay, and Anup, I've already shared the code with the backend team. They will probably upload it tonight. Okay, so please make sure that uh, you know uh, yes, and there will be a lot of things that are going to come up. Okay, because many people will discuss about different things. They want the things, and today is the last session of stats. QQ plot I have already uploaded in one of the video. Again, it will probably take 15 to 20 minutes in explaining everything again, right? So I think from the playlist you can definitely see there is something called as transformation. So today is the seventh day. Now the first topic that we will discuss about p-value and significance value. See, yesterday we had a lot of confusion regarding this, right? So today I'm going to talk about the exact relationship between this p-value and significance value, because from the tests that we were doing, we were seeing that, okay, most of the tests, from that test, how do we derive this p-value? That is what I'm actually going to discuss about it. And practically also one example will be shown. Then we'll move towards distribution. Okay, first we will discuss about central limit theorem. Then we are going to discuss about distributions like Bernoulli distribution. Then fifth, we are basically going to discuss about binomial distribution. And then sixth, we'll also be see something called as Pareto's distribution. So we'll try to complete up all these things. And again, guys, please, as you all know, iNeuron has already come up with this one neuron platform where we are providing all the tech courses for lifetime in just one price, that is 7080, right? And if you feel this is more, use Krish 10, okay, to get 10% discount. I would suggest try it, because this platform will be quite amazing. Okay. Bonani, please don't spam. I'm going to, otherwise you'll not be able to message it. Okay. So 10% discount you'll be able to get it by using this code, that is Krish10. All the information regarding the course is given in the description of this particular video. Okay, I'll include log normal also, right? Log normal distribution, right? So we'll start in another 1 minute. Yes, Poisson distribution also I'll be discussing. Don't worry. Poisson, Pareto distribution. There is something called as power law. We'll discuss about it. Okay. So one final thing that is pending is called as F test, which is also called as ANOVA test. This will take 1 hour time, guys. Just to do this, I will upload a separate video. Okay, I'll upload a separate video. on the same. Okay, so please, we will be doing all these things, and let's say that in ANOVA, I'll upload a separate video because this is going to take more than 1 hour. It is important because there are multiple steps to complete this F test. Okay, and yes, this 7 days statistics is more than sufficient for data science, whatever we have learned. There is some videos that you have to check to how to do practical implementation with respect to transformation, like how do you transform the data based on one distribution to the other distribution and everything. Okay, so yes, support us to become the most affordable education ed tech company. Okay, so that is the reason why I'm telling you in 7080 you are getting many things as such. So let's start the class. So yesterday, how many people had confusion with respect to p-value and significance value? Today, I will show you how you will derive the p-value. Okay. So we are basically going to see how do we derive the p-value and what is the relationship between p-value and significance value. Okay. So this all things we will be discussing. Let's take a problem statement. The problem statement, I'm going to take it off as that test. Okay, and let's write down the question. Before that, everybody ready? Take up your book and pen. I've already discussed about permutation and combination, guys, in the previous session. Okay, so quickly just say me you are ready. I'll start solving the problem and hit like. Okay, we'll make this last session an amazing session. Okay, so let's go ahead and let's try to understand the basic difference between p value and significance value. Okay, so quickly, are you ready? Just give me a thumbs up and then probably I'll start. Okay, okay, perfect. Many people are ready, so let me write down the question. The question is nothing but it is very simple. The average, we'll do a z test problem and then we'll try to derive this. The average weight of all residents in, let's say, in Bangalore city, is 168 pounds or 168 pounds, let's say. Okay, so we take a sample. Now take a sample. Okay, one data I have missed. So over here, the average weight of all residents in Bangalore city is 168 pounds with a standard deviation 3.9. Okay. Now what we are saying, we take a sample of 36 individuals. We take a sample of 36 individuals and the mean is 169.5 pounds. Okay. So from this information, we really need to check whether this sample is being able to tell us the weights are same or not. Okay, so this is what it is given and our confidence interval is basically 95%. So what test we can definitely use for this, guys? Quickly say what test we can definitely use it. Okay, Gautam, you can make it kgs also, right? So z test, right? So over here, you know what is your mean? My mean is 168 points. The standard deviation is 3.9. The x bar is nothing but 169.5 and my n sample is greater than 36. And obviously my n sample is given, my population standard deviation is given. So I am going to basically use z test. Very good. The alpha value is 0.05. 1 minus 95% is 0.05. Okay. Now, let's go ahead and solve this particular problem. So what is your null hypothesis? Mean is equal to 168. What is your alternate hypothesis? Your mean is not equal to 168. Okay. Okay. Then what we do? We basically come to the second step where we specify our alpha 0.05. The third step, we basically find out our decision boundary. So my decision boundary is quickly how much? It is nothing but it is this graph. It is a two-tailed test. It can be greater than 168, less than 168. So here I have basically 0.025. Here I have 0.025. Here I have 95%. Now what is this value that I can get from the Z table that we see? What is the value that we are getting with respect to Z table that we see? Anybody? Can I say 1.96 plus minus 1.96? Yes. Do I get this? Yes or no? Everybody, if you open a Z table with respect to 1 minus 0.025, you will be getting 0.9750, right? So we are going to check this area of curve, and usually we get 1.96 and minus 1.96. Okay. Now the next step, I hope everybody is clear because we have already done this in our previous session. Okay. Next step, we do that is my fifth step, we calculate the Z test. Now Z test formula is very much simple. I hope everybody remembers it. X minus mu divided by standard deviation of root n. What is X? What is X? X is nothing but it is average. Okay. 169.5 minus 168 divided by what is standard deviation 3.9 root by 169.5 guys, not 1 root of 36, right? So here we are basically going to get 169.5. Let's open the calculator. So 169.5 minus 168, which is nothing but 1.5. 1.5 divided by 3.9 multiplied by 6, right? So what it is? What it is, guys? 5 multiplied by 6 divided by 3.9. It is 2.307. Okay. So 2.307. So right now, let's go to our decision rule. My Z value is 2.307. Is it greater than 1.96? It is greater than 1.96. So we reject the null hypothesis. Fine. Right? But this is already we have done many number of times. Okay. We have done many number of times. But now one step will go ahead. This is fine. This is one way of solving this problem. But where does p value comes into existence? Okay, where does p value comes into existence in this particular case? Now what it is saying is that initially my this graph I was checking it for this to this where it was plus 1.96 minus 1.96, and obviously I got 2.307, so it is falling somewhere here, right? It is falling somewhere here, right? If I'm considering 2.307, it is falling somewhere here. It is on the top hand side. right? So we are rejecting the null hypothesis. Now, if I really want to find out the p-value, what I am actually going to do, I'm going to remove this. I'm going to remove this. And now my curve will be a little bit bigger because based on this, I got the z value as 2.307. And here also I got minus 2.307 because both are symmetrical, right? Now the next step, what I will do, I will take out my z table. I will take out my z table and I'll try to find out what is those values with respect to my z score, with respect to my z score, with respect to my z score of how much it is 2.307, 2.307, right? So what I'm going to do over here, 2.3, I'll check based on this z score, what is the area under the curve? What is this specific area? What is this specific area? I really need to find out, right? And I don't know what is the area right now. So I will go ahead and calculate it. Now based on 2.307, okay, so 2.3 is here and 0.7. If I say 0.7, it is somewhere here, right? So 2.307, I am getting somewhere around 0.99111. Do you see this, guys? 0.99111. Is everybody getting it? Yes? I hope everybody is able to understand what I am getting over here, right? 0.99111, right? So what I am getting over here, it is nothing but 0.99111. So here, based on this, my area under the curve is basically 0.99111. I hope I'm writing it right. 2.3, 0.99111. I hope everybody understood this. So this, with respect to the area under the curve, I'm actually getting this, right? Is clear? Everybody is clear with this or not? Just tell me. Yeah. If you are clear, then only you'll be able to understand the further things. Okay. Now understand one thing. If I subtract with 1, see 0.99111 is basically the area under the curve of this particular curve. Now if I subtract this with this, how much I will be getting? How much I will be getting? So what is the value that I will be getting? I will be getting 1 minus 0.99111, right? So how much I am getting? I am getting 0.0081. So this area is nothing but 0.0089 and this is nothing but 0.0089, right? So I am getting 0.0089, 0.0089, right? So this, you can see this 889, sorry, it is 889, 889. So here I get 89, here also I am getting 89, right? Now according to the p-value, now see this middle one is 0.99111. If I add up all this particular value, I should be getting 1. And if you add it up, and probably you'll be getting 1. P-value is nothing but I have to add this area of curve of this tail and this tail because it is two tail. I have to add this up and then this will basically give my p-value 0.00889. So once I add this particular value, so what I'm actually going to get? What I'm actually going to get? These guys, they are really irritating. They don't come for studying. Instead, they come for spamming. Okay, I like to remove these guys permanently from my channel. YouTube should come up with some kind of options, you know. So if I add up this two, so what I'm actually going to get? I'm actually going to get 0.01778, right? Is it not 0.889 divided by 2? No, because see, both the area are symmetrical. Understand one thing, both the area are symmetrical. If I am getting one value over there, okay, if I am getting one value over there, probably I'll be able to see that specific part, right? Because this part is symmetrical to this part. Do you think it is divided by 2? Do you think it is divided by 2? No, I don't think so. It should be divided by 2. It is basically considered at this part and this part, right? Something like this. Is it okay, just a second. 0.99111. Oh yeah. Should we divide by 2? Yes, yes. Then only probably I will be able to. Okay. So probably we are getting more than 1. So over here, I'm getting 2.307. 2.307 is greater than 1.96. With respect to 2.3007, I am actually getting the value as 0.99111. Okay. So 1 minus 0.99111 will be nothing but point. Yeah, I forgot to subtract 0.99111. So we are subtracting, we are getting this. If I divide by 2, so this will basically be your area. Just a second. I will just rub this. I will also rub this. Okay. So we have to divide by 2. Yes, guys. Then otherwise the overall area of the curve will be greater than this. So I'm going to take this 0.0044. Okay. So 0.0044. This area 0.0044. Now if we add it, we will be getting till 1. Okay. Perfect. Thank you, everyone. Now, in order to add the get the p value, I will take this area 44 plus 0.0044. Now, here you can see that I am getting 0.0088, right? Now, this is basically my p value, okay? Because based on the real z score that I have got, I'll be deriving my p value from here, okay? Now, obviously, we know that we have to reject the null hypothesis. Now, from the p value also, we can actually verify. Here, now this p value is obviously less than 0.05, right? Which is my significance value. So, obviously, 0.0088 is less than 0.05. So, what happens over here? We basically reject the null hypothesis. We reject the null hypothesis. Okay. So here we are rejecting the null hypothesis. Suppose if this p value is greater than 0.05, okay, again spammers. Everywhere there are spammers. Really. Okay. So now we are going to reject the null hypothesis. Now in this particular case, we are rejecting the null hypothesis over here. Okay. Always understand two important points. One is p value is less than your significance value. I hope you understood how to calculate the p value, right? So if this is less than or equal to the significance value, this means we have to reject the null hypothesis. That basically means, okay, if the p value is greater than significance value, then what we do? We fail to reject the null hypothesis. We fail to or accept the null hypothesis. We fail to reject the null hypothesis. Now it is clear, guys, from the yesterday's session. Now you can try out in every problem that we have probably discussed this many days. Now is it clear, everyone? Now is it clear? Do you want to try with t-test also once? Do you want to try with t-test also? You can also try it with t-test. Whatever you want, you can try with it. Right? But I hope everybody is understanding, right? Yes? The Z table part wala short में समझाइए. Okay. See guys, whenever we have a Z table, right? Right now, one thing is that first of all, I'll check with 0.025. 1 minus 0.025 is 0.9750. So if I go and see, probably somewhere you'll be able to see 0.9750, where it is here. So it is nothing but plus 1.9 and this is 6, right? But we saw that our real Z score was coming as 2.37. right? 2.37, 2.307 or 2.37, 2.30. What was our this one value with respect to this? 2.30. So I think I messed it up or what? 2.30 is this one. Okay, guys, 2.30 is this one. I took 2.307. Okay, so again, there was a confusion over here. You can also take this one. See, 1 minus 0.9828. 1 minus 0.9828. You can also do this. 1 minus 0.9828. So if I subtract this 1 minus 0.9828, 1 minus 0.9828. So I'm actually going to get 0.0172. If I divide by 2, this will be 0.0086. Okay. So you can take this up. Okay. Again, I'm going to repeat this. Okay. Let's say I'm planning to repeat it. Okay. Fine. Not a problem. See, initially what I got, my value was this, right? I got this as minus 1.96, this as plus 1.96, right? But based on the z-score calculation, how much we got with respect to z-score calculation? Here you can see I got 2.307. Okay, 2.307. So here I'm actually going to get 2.30. Okay, let's take this. So obviously my z is 2.30. It is greater than 1.96. So I've told you we have to reject the null hypothesis in this case. This is with the help of z-score. Okay, reject the null hypothesis. Okay, now what I'm actually going to do, let's calculate the p-value. Now in order to calculate the p-value, okay, what I will do, I will rub this and I'll try to find out the area with respect to this z-score, that is 2.30. So plus 2.30 minus 2.30, and I will try to find out what is this area, and based on this I will be able to find out this area also. Okay, so let's go ahead in the z table now. So this is my z table, 2.30. Okay, 2.30. So here is my value, 0.98. See this, guys. I'm again repeating it, 2.30, right? This is my z-square value. So 0.98928. Okay, so here I'm actually getting 0.9828, right? So this is my area under the curve, 0.9828. I guess 0.9828 only, 2.3, 0.9892, sorry, 0.98928, 928, okay, 0.98928, 928, okay. Now when I subtract 1 minus 0.9828, then I will be getting this area and this area, right? Since I will have to get this particular area, so I have to subtract with the whole 1. So if I go and calculate now, 1 minus 0.98928, so it is nothing but 0.0171072. Now understand, this is not one tail test, this is two tail test. So I have to divide the area from here to here also, right? So that is the reason why I divide by 2. So I'm going to divide by 2. So I'm actually going to get this as 0.00, just a second, 1 minus 0.98928 divided by 2. So it is nothing but 0.00536, then 0.00536. In p-value, I will add this two term. Okay. Understand, guys, what I am actually trying to do. You have to check out the Z table. So if I add this, probably, then I will be getting some value, and then check whether this is less than significance value, less than alpha, less than or equal to alpha, then you reject the null hypothesis. And obviously this case also it will be less than this one. Everybody clear? Mahmood Bilki, it is two-tail test, right? So that is the reason I divided by 2. Everybody clear? Yes? Okay, perfect. Don't worry, I'll make a dedicated video in my YouTube channel for the same problem statement. Okay? Okay. Now let's go ahead and let's discuss about the distribution part. Okay? Why did not take 3.307 table? There is no 2.307. See, it is 2.30, 2.31, 2.32, 2.33, 2.34, 2.35, 2.36, 2.37, 2.38, 2.39. Okay? Everybody clear now? Okay. Okay. Do you want to solve more problems in this? I'll be happy to solve. ये प्रॉब्लम नहीं समझ में आया क्या किसी को? सेम थिंग है ना? How to understand whether it is a two-tail test or not? That is what is I am saying, right? In two-tail test, we don't, you don't see. This is the last day of this thing, right? I've repeated again and again, right? I've repeated again and again all these particular problem statements, right? Okay, let's solve one more problem. Let's see. Let's solve this problem. So, the average age of a college is 24 years. Okay, with a standard deviation 1.5. Okay, so this is a college over here. Please guys focus over here, otherwise you will be confused throughout your life. Okay, so average age of a college is 24 years with a standard deviation of 1.5. Okay, now what I am actually going to do over here is that I'm just going to say that, okay, fine, the average age of the college is this much. So we take a sample of 35 students. Let's say that the mean I have given the mean right over here. We take a sample of 35 students, and we find out that the mean is 25 years. Then with alpha as 0.05, that is the confidence interval as 95%. Okay, with alpha as 1 point alpha as 0.05 and confidence interval, do the age vary? Okay, so this is the question. Now do it guys quickly. H0 you'll say mean is equal to 24. H1 you'll say mean is not equal to 24, right? You know your standard deviation, it is 1.5. You know your n value, it is 35. Let's take it as 36. Okay, 36. This is 36. Okay, let's consider this as 36 so that your calculation becomes easier. 36, right? And then your x bar is 25, right? And your alpha value is 0.05. Okay, now tell me whether this is a two-tail test or one-tail test. First of all, think over it, guys. You really need to be patient in solving this problem. Okay, I know half baked knowledge will not come into use. Okay, it's a two-tail test, right? So here you have your alpha as 0.05. Now if I make my confidence interval, my decision tree, sorry, my decision over here, this will be 0.025. Why 0.025? This 0.05 will be divided into two regions since it is two-tail test. If it is a one-tail test, focus over here only, no? Focus over here only to solve it. Why you don't have to worry about all those things, Then let's go and solve with respect to z score. Z score x bar minus mu divided by standard deviation by root n. So what is my x bar? It is nothing but 25. 25 minus 24 divided by 1.5 multiplied by 6. Right? So it is 1 multiplied by 6 divided by 1.5. Go and calculate it. Go and calculate it. 1 multiplied by 6 divided by 5. So it is nothing but 1.2. The z score is 1.2. You know the decision boundary. What is the decision boundary? Plus 1.96 plus 1.96. Right? Now you are getting 1.2. Okay. So if you are getting 1.2, then obviously 1.2 is less than 1.96. Should we reject or accept the null hypothesis? 4? Are we getting 4? Oh, sorry, it is 4. Extremely sorry. 4, right? Now, if you are getting 4, the 4 is greater than 1.96. So we reject null hypothesis. We reject the okay. हाँ भाई, अब मार ही दो तुम लोग. हो गया गलती यार. We are doing it right. You got the answer. Great, amazing, congratulations. You have won a Nobel Prize by telling me that I have done a mistake. Okay. Now what you are going to do for this particular 4? You have got a 4 value, right? So this will be your plus 4. This will be your minus 4. Now go to the Z table. Try to find out what is the 4 value. Right? Right? What is your 4 value? Right? So go over here. Try to find out what is 4. It is 0.99997. 497s, right? So it is 0.9997. 4 nines, right? 99997. It is not max till 3, no, max till 4 is there. Okay. So I will go and subtract this to this. Now if I subtract this to this, what will happen? One minus 0.99997. So what I'm getting basically, and I have to divide this by 2 since this is what? Two-tail test. So this side will basically be my area as 0.004015, and this will be my area as 0.4015, and this middle one will basically be 0.9997. Now what is my p-value? My p-value is 0.00015 plus 0.00015. So what this will be? This will be nothing but the same thing, 0.403. 0.403. Now my p value is obviously very, very lesser than significance value. So what we have to do? We have to reject the null hypothesis. Reject the null hypothesis. Ali Hassan, you are not attending my sessions. I cannot repeat again and again why this is two tail or one tail. Understand the question. No, the average value can be greater than 24. It can be less than 24, right? It can be equal to 24. So it becomes a two tail test. Did I say that? Did the age increase? Right? If probably I said that the age is increasing at that point of time, I can definitely say that it is a one tail test. अब समझ में आया everybody? Difficult to make everybody understand and satisfied. That is the problem. Okay? Energy is done. I don't know what will happen when I take live sessions on machine learning algorithm. I have to convince people. So here you can definitely say that with the sample size that we have taken, definitely we will not be able to conclude that the mean is that much. Right? So let's go ahead with log normal distribution. I've already discussed about log normal distribution, but again I'm repeating it. Okay. इससे ज़्यादा कोई नहीं समझा सकता, ऑब्वियसली कोई नहीं समझा सकता यार. माई थ्रोट इज लाइक, देखो गर्म पानी पी रहा हूँ मैं, देखो गर्म पानी पी रहा हूँ. ऐसा हो गया गर्म, पहला दिन रेड बुल में था, उसके बाद अब लास्ट के दिन गर्म पानी में हूँ. लाइक्स भी नहीं करते, लोग भी नहीं आते. राइट. ओके फाइन. नाउ ये आयुष इज सेइंग इट शुड नॉट बी डिवाइडेड बाय 2. ओके. Okay, guys. So log normal distribution, usually log normal distribution, it will have this kind of shape. Obviously, we have seen a lot of examples like wealth distribution, right? Or you can consider Ayush Mehra is saying 1.96 kahan se aaya? This is like the entire Ramayana is finished and he's saying who is Sita. 1.96 कैसा आया भाई? कैसा आता है 1.96? बताओ ये 1.96 कैसा आता है? हम्म. ये अल्फा वैल्यू के बेसिस में आता है ना भाई. हाँ. आयुष, पूरा रामायण खत्म हो गया. तुम 3 दिन से यही चीज करवा रहा हूं मैं. हाँ. ओ माय गॉड. यार सिर्फ पढ़ाना नहीं होता है, रिवाइज भी करना होता है चीजों को. वीडियोस यूट्यूब में भी डाल दो, हटा दूं क्या यूट्यूब से वीडियोस तो? है. ओके. अरे बहुत कॉमेडी कॉमेडी हमारे साथ मिलते हैं. सोचो हम लोग ने इतना सारा ऑप्शन दे दिया वन न्यूरॉन में, ऐसे ऐसे मैसेजेस आते हैं ना. हम लोगों को रिक्वेस्ट आता है कि लाइक वी गेट रिक्वेस्ट सेइंग दैट क्रिश अपलोड फ्रेंच वीडियो ऑल्सो, अपलोड जर्मन वीडियो ऑल्सो. सम गाय इज सेइंग मी upload data science in Tamil, in Telugu. Okay, lot of things, right? So a lot of requests is usually come, and we are really people facing company, right? We have to handle, so many queries. It is so tough, guys, so tough. Daily we are replying to 2000 queries. Okay, 2000 queries. Just imagine. People will say, okay, they will probably hear name from somewhere, some technology name. and they will come and directly say, I want the course on this technology. Okay, we literally have to go and google that technology and then think, okay, this thing also we need to upload, like that, right? The course request too much funny, like this, any kind of course request will come. Some guy will come and say that, okay, I want a course on this specific technology in my office, they have told me to learn this. So it is very, very difficult, very difficult, trust me. Every day 2000 emails, and you'll be seeing that email. No, it's like, oh my god, why I'm going home, like that you'll think. आजकल तो नींद में, सपने में भी वही चीज आते हैं. ओके, सो इट इज वेरी डिफिकल्ट गाइस, ट्रस्ट मी. अब पीपल, लोग भी कुछ समझते नहीं है. और आजकल ना कोई वन न्यूरॉन लेता है ना, पहला वो देखता है, अगर समझे, लाइक इफ इज गोइंग टू सी AWS, ओके, ही विल ओपन AWS कोर्स, he will go throughout the entire topics, okay, he will go throughout the entire topics and he'll see that which topic is missing. He will go and see which topic is missing, and he'll raise a request saying that, and that particular topic is the last of the course, okay, because we say that we are updating the courses, right, because we keep on adding more things, okay. So that guy will go and write, oh, this topic is not there, why have you not uploaded this topic, oh no, this comes in the advanced section. Then they'll never go throughout the entire course, okay. They will just go and see which topic is missing, and then they'll try to raise a question on that specific topic. It is like out of the box completely. Okay, so this kind of situation will also come in your life. It's very difficult running a company. आप लोगों को तो you'll think like, hey Krish, you are doing this, hey, you are doing this. आओ, you come and work in our one day as a company. बाल झड़ जाएंगे, ठीक है, पता नहीं चलेगा, एक ही कपड़ों में दिखोगे, ठीक है. You'll only see me in one cloth. Okay, go and see my previous video. I'm just repeating the clothes. Okay. So like this kind of situations you'll be getting a lot. Okay, it is like literally. Okay, day before yesterday, what happened? We uploaded first phase of blockchain. Okay, then we uploaded second phase of blockchain. Okay, two phases are done. Now suddenly a person will raise a query, I need a course on metaverse also. He doesn't know blockchain, but he's raising a question on, I need metaverse also. Okay, so आई एम सेइंग भाई पहले पढ़ तो लो, आ जाएगा मेटावर्स भी. सबको जल्दी जल्दी वही चाहिए, सब कुछ चाहिए, हैं. इट्स लाइक वी आर गिविंग इट फॉर लाइफ टाइम, राइट भाई. जिंदगी आराम से जियो ना, आराम से क्वेश्चन पूछो, आराम से कोर्स पूछो, ठीक है. Then first they'll go and see what all topics are not there, what all my courses are not there, and they will just upload those, right? So बहुत जिंदगी बहुत कठिन हो गया है. ओके, now if I'm doing live sessions also, no, then they'll say that why you're doing live sessions. यार काम छोड़ दूँ, कम्युनिटी सेशंस हम लोग करते हैं ना, काम छोड़ दूँ मैं. बहुत सारे. So you'll find lot of people. So we have become very good in talking with people and understanding their problem. Okay, like this things happens. So I don't know, like seriously. Hmm? Seriously. कोई नहीं, you see my face in the first class and now see the face in the 7th class. I'm literally tired and today's Saturday. Okay, so कौन सा भी टेक्नोलॉजी पढ़ लो भाई, शांति नहीं मिलेगी, ठीक है. इट्स लाइक शांति मिलेगी ही नहीं. ओके, उसके बाद एक बंदा, वन गाय हैज रेज्ड अ कोर्स रिक्वेस्ट, आई वांट हाउ टू रन अ यूट्यूब चैनल फ्रॉम कृष्ण नायक. Like this kind of request will come. Oh my god. Okay, let's go to the log normal distribution. So the example is wealth distribution. Have you seen wealth distribution? There are very less number of people who will be having huge wealth, and there will be normal salaried people like me, you know, who will be in this region. Okay, we cannot come in this region because we are a customer facing client. Okay, so these all things are actually there. So this was the example of log normal distribution. Now suppose I say that if if y is a random variable that belongs to a log normal distribution with mean as with some mean Let's say that this is there. It belongs to a log normal distribution. Then if I apply log of y, then it should follow a normal distribution. Okay. So if it is satisfying this condition, we can say a distribution is basically in this kind of log normal distribution. So log normal distribution I have already discussed in the previous session also. A lot of examples are there. People writing comment session, people writing bigger comments, people writing, there will be very less number of people who write big comments, right? Big comments. So this is one example. Okay. And again, this is also, I have uploaded a detailed video in my stats playlist. Let's go to the next distribution. If I say that next distribution is there, so I will talk about Bernoulli's distribution. Bernoulli's distribution. Okay. So Bernoulli distribution, see guys, that only I'm telling. No, now some people are saying they're improving iNeuron. Yes, we are trying to improve this particular platform. Just imagine on the idea, right, on what we are working. One tech platform where you just pay some affordable money and you get it throughout any course that you want to raise, you can raise a request. Now, I mean any course, literally any course. That does not mean literally any course. Okay. So you'll be saying, oh, I require. Some people have also raised, I want some kind of gaming courses also. Then we have accepted it and we are probably also uploading it. So it's like, see, a company grows by the kind of things that we provide. A company becomes successful with the kind of things and services that we provide. And this is really mind blowing services that what we have included, you know. But some people, they like, oh my God, they literally, I don't know, like if you are somewhere in, like all these services, see, just understand the importance, okay? The thing is that what problems you are facing right now. You did your college, you did your engineering, you did any kind of degree. Every year you invested so much of money. Just imagine lakhs and lakhs of money you invested, right? How much money did you invest in your education, guys? Just tell me. Literally, you can comment me. Let's discuss all these things later on. Okay, Bernoulli, binomial, and all, they are simple distribution. Just imagine how much money you have invested in your education. Just imagine how much money you may have probably invested in your education. Okay, every year, right? When you are in college, how much you have invested, right? Like lakhs and lakhs of rupees you have invested, guys, if I consider your hostel fees and everything over here, right? It's quite huge. I got my engineering seat, which is completely for free based on merits, right? There also I used to get some kind of scholarship. Okay, but I can understand because I used to see my friends who have invested huge amount of money. And the money is precious, guys, because see, if I see my friends parents who are like normal, from middle class background, they used to come and take the cash and come and give it to the college people. I used to feel really bad about it, because for a middle class family, the money is quite huge. That specific money is quite huge. Okay, very very huge, right? It is very huge, guys, right? So just understand that money that is earned at that point of time, it's very very important how it can be used in various ways. अब वो हम लोग सीधा सीधा जाके जहाँ दे रहे हैं, I don't know whether you, and the return of investment is very less when you're investing that much money. Now when we say 7,000, they are saying, oh Krish, this is a huge amount of money, या एंटायर भाई तुम्हारा पूरा कॉलेज का डिग्री कंप्लीट हो रहा है इधर. Your entire college is getting completed over here. That is the plan of one neuron. You know, this people do not understand. And I definitely cannot make everybody understand. Okay. There are many people who will say that Krish is doing business. Bhai, business nahi kar raha hu. Literally, I can just take my YouTube channel, daily upload one video. I can survive throughout my life. I can do sponsorships. I can do multiple things. I can earn huge amount of money, right? Many people come for me for sponsorships. I can come and do it. An integrated video will give me a good amount of money, right? But just understand. But I see some comments from people saying that, Krish, you are doing business. या बिजनेस करना होता 1 लाख रुपए रखता ना, 1 लाख रुपए रखता मैं कोर्स का फीस, 2 लाख रुपए रखता कोर्स का फीस, मजबूर कर देता। अब 1 ईयर ऑन प्लेटफॉर्म में 7,000 रुपीज है। यू हैव 100+ courses and we will make sure that in the upcoming 2 to 3 months we are going to make that particular course amazing and extensive, where we are including probably everything, right? Understand one thing. So sometimes it becomes very difficult to make people understand. They don't know. I think the decision making skills has completely gone nowadays. I don't know what people think, but what kind of decision making they have to do, they'll do. But at the end of the day, finally I get a lot of messages in LinkedIn and all saying that, Krish, I'm facing this problem, I've done this, I've invested so much money but nothing, I'm not able to get job, you know. So this is what is the decision making skills, right? People have gone. अब वहां पे हम क्या बोले उनको? I can only guide, right? I can go and say, okay, you have invested that much money, go and follow my free resources in YouTube and try to implement a lot of projects and then try to get the job. That is what I can say. What more I can say? Everything. You know how much videos I have uploaded in my channel? More than 1300 plus, right? So these things are very much necessary, guys. I know I have taken your 10 minutes, which was, I don't know, many people will then again say, Krish, why are you wasting time? Oh, we are good decision makers. Okay. Okay. So let's talk about Bernoulli distribution. Okay. Let's start over here and talk about Bernoulli distribution. Now in Bernoulli distribution, you can see that it's more about P and Q. It's more about, see, whenever you have a Bernoulli distribution, that basically means you need to understand there are only two outcomes. So if I go and probably open it over here, in Bernoulli distribution, there are specifically two outcomes. Okay. Two outcomes basically means that it can be either 0 or 1. Let's say that I have two outcomes of 0 or 1. But I really need to find out the probability, you know, when we need to focus on probability with respect to Bernoulli distribution, we define by two values. One is P and one is Q. Suppose I say I'm considering an experiment which is called as tossing a coin. In tossing a coin, I know what is the probability of head. Let's say that I'm getting probability of head as 0.5. So this will basically become my P value. Okay. When I talk about the Q value, it will become 1 minus P. Okay. That basically means it's the probability of head, because when we are probably tossing a coin, okay, there are two choices. Either you get head or either you get tail. Okay. So when I say probability of head is 0.5, so this is what one outcome probability is there, right? What about the other outcome? So that is nothing but 1 minus P. So here if I have 0.5, then Q will be 1.5, then this will be 0.5. Okay. Suppose I do not have a fair coin. I do not have a fair coin. Do not have a fair coin. Now in this particular case, and this is only related to single trial, not multiple trials. Okay. Single trial distribution. Now let's say that I do not have a fair coin. Let's say that my probability of head is 0.3. Now in this particular case, what will be my probability of tail? This is basically P. Then my probability of tail will obviously be Q, which is nothing but 1 minus P, which is nothing but 1 minus 0.3, 0.7. Okay. So this is basically 0.7 over here. You can see over here. Now, similarly, if I go and probably discuss with respect to this, here you can see that a Bernoulli distribution named after Swiss mathematician Jacobi Bernoulli as a discrete probability distribution. Okay. Now here you see this. Okay. Three examples of Bernoulli distribution. Here the probability of x is equal to 0 with one of the outcome is 0.2. So we are drawing this graph. This line. See, this will come as 0.2. This will come as 0.8. Okay. This will come as 0.2. This will come as 0.8. Okay. So 0.8, 0.8. Over here, next outcome you can see over here is 0.8 and 0.2. So this is how you basically create in this 0.8 and this is 0.2. In the green color, you can see 0.5 and 0.5. So this is my 0.5 and 0.5. Now understand one important thing. Okay. Whenever we draw this kind of experiment, if we draw in the form of graphs, on the left hand side, obviously, you know what will be there with respect to this, and the right hand side, there will be probability. Okay. So this is basically 0.2, 0.4, right, 0.6, 0.8 and 1. Okay. Now suppose let's consider that I have one coin over here. This one coin is basically head, this is basically tail. Now if I try to show you with respect to the probability of head and tail, I can basically draw. Suppose if I say this probability of head is 0.5, so I can draw this line like this. I can basically draw this line with respect to this and this. Just a second. Then if I'm drawing this line, then probability of tail will also be 0.5. Okay. Suppose if I say the probability of head of not a fair coin is nothing but 0.8, then we will draw a line like this. Okay. Here I can basically say then what will happen if this is 0.8, then this will become 0.2, right? So this is how we basically draw this, and this is not a probability density function. Understand? This is a probability mass function. Probability mass function. In probability density function, it is completely different. Probability density function is for continuous variable. This is specifically for categorical variables. So this probability mass function that we have over here, we will basically say it as PMF. Before we used to say it as PDF, right? So whenever we have this kind of variables, categorical variables at that point of time, okay, this is basically called as probability mass function. Okay. So I hope everybody is able to understand with respect to this. Now let's go to the Wikipedia page. So here you can see probability mass function, and the same thing probability mass function is saying. If k is equal to 0, I will write q is equal to 1 minus p if k is equal to 1, right? And the PMF is basically defined in this particular manner. Any probability that I want to form, I want to find out, this is how the formula is basically utilized. Okay. We really need to know only this much things about the distribution and one probability formula. Okay. So this was with respect to Bernoulli distribution. Now let's go ahead and try to discuss about binomial distribution. See, binomial distribution is also very much good. Till now we discussed about single trial, right? Single trial, whenever we take up multiple trial, then it becomes a binomial distribution, right? Inside this, let me write it down over here. So if I go and see with respect to binomial distribution, binomial distribution says that obviously with respect to every trial, there will be a Bernoulli distribution. Bernoulli distribution, but here we have multiple trial. Multiple trial. Okay. That basically means we have the combination of many Bernoulli distribution over here. Okay. Suppose in this trial, my probability of head is this much. Suppose in one more trial, I will go and write probability of head is 0.6. This is 0.4. Like this, I will be having many trials combined together in one kind of binomial distribution. Anup Srivastava, I told you, right? Whenever you have a categorical variable and whenever we try to draw this kind of diagram, then it is called as a probability mass function. In the case of a continuous variable, we have probability density function. Okay. I hope everybody is able to understand, guys. Yes. 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 Just let me know if you are able to understand this or not. So if I go and probably see this, you can see that the binomial distribution is given by two notation, n comma p. Okay. So n is nothing but number of trials, p is nothing but success or probability for each trial, where q is equal to 1 minus p. Okay. And this is the formula with respect to the probability mass function to calculate the probability of a binomial distribution. Okay. I hope everybody is able to understand it. Okay. Now this is done. Now let's go to one very important distribution which is called as Pareto distribution. Pareto distribution, Wikipedia. I'll again open Wikipedia because it will be amazing. Now Pareto distribution is a non-Gaussian, it is not a Gaussian distribution. Okay. It looks something like this. Okay. One application of Pareto distribution is nothing but power law distribution. So if I show you power law. So here everybody see this diagram with respect to this. I'm just going to take a snippet of it. We'll discuss about this. This is something very much important. Okay. Let's paste it over here. Now in this particular case, when we are discussing about power law distribution, let's see that what important information we can take out from this. Power law distribution basically says that you have to remember this rule, which is called as 80-20 rule. Okay, you can see that this is probably my 80 percentage of this entire value, and this is my 20 percentage of the entire value. Okay, my x-axis may be something, my y-axis may be something. Okay, but understand the 80 of one kind of distribution will be falling here and remaining 20 will be falling here. Let's say take some examples. Okay, now suppose if I say that 80 percentage of the wealth is distributed with 20 percentage of the people. Okay, the second question, any example, any other examples? Just think of any other example. Any other example? 80 percentage of the wealth is distributed with 20 percent of the. Can I say 80 percentage of the company projects are done by 20 percentage of the people? Are done by 20 percentage of the people. 20 percentage of the people in a team. होता है ना यार? Right? Some more example. Okay. Let's take one more example. 80 percentage of sales is done by 20 percentage of the most famous product. 20 percentage of the famous product. Right? Any example? More. Okay. One more example I can take. 80 percentage of the match, cricket match, okay, let's say, is won by 20 percentage of the 20 percentage of the team. Right? 80 percentage of videos are completed by 20%. 80 percentage are serious out of all the 100%. Right? Like 80 percentage of the syllabus are completed by 20 percentage of the people. Right? 80% spamming on YouTube video has been done by 20 percentage of the people. Yes, any kind of examples you can basically take. You can also consider salaries. You can also consider, yes, 80 percentage of oil coming from 20 percentage of the land. Amazing. Very nice. Very nice example. So whenever you have what this kind of distribution, it is called as power law distribution, and this is also called as a Pareto distribution. Now, listen to me one thing, guys. This is something very much amazing. Right now, this diagram that you see looks something like this. Looks something like this, right? If I extend this diagram and probably make it like this, if I probably extend this diagram, if I extend this diagram and make it like this, see this is a very important thing. Then what kind of distribution this is? What kind of distribution this is? This is my power law distribution. What distribution is this? This is not normal. This is, can I say this is log normal distribution? Log normal, guys, not normal. The right hand side over here, this will get extended by a lot. Log normal distribution. Okay. Probably I did not draw the diagram properly, but it is a log normal. Log normal, right skewed data. Something like this, let's say. Okay. So this specifically is a log normal distribution. Okay. So there is a very good relationship between log normal and power law distribution or Pareto distribution. Okay. So mathematically, if I talk about, you can also convert this distribution into normal distribution also. Okay. And for this, you have to watch one of my video, which is called as transformation, data transformation. I think I will be able to find that video over here. Let's see. Just a second. I will find out that particular problem state. So all the different types of transformation in machine learning, whether you can convert this or not. So I've given the link. You can check it out whenever you have time. But remember, this is an important video. Okay. Okay. So definitely check out those video, and probably this is what is basically spoken about it. So that is called as Pareto distribution with respect to this. Okay. Now, guys, yes, box cost transformation is basically used in order to convert this data into normal distribution. So probably you will be able to see from that video link that I have actually given. Okay. I can also show you the code. So this is how the code looks like. I've covered everything, guys. Now it's your time to flourish and learn everything. See over here, all the transformation, normalization, standardization, scaling, this, square root, everything is given over here. So this is here. I have also discussed about QQ plot. So if I go and probably show you, see. So all the transformation is basically used. I've used all the transformation in this. You have to follow that video, guys, because it will probably take me 1 hour to explain all these things. See, this is what is QQ plot is, right? Reciprocal transformation, logarithmic transformation. Then you have Gaussian transformation. These all transformation are the logarithmic, reciprocal, square root, exponential transformation, Box-Cox transformation, right? So all this transformation is basically used in the initial stages. We basically apply with respect to all the features. Okay. And then we'll be able to, can I say this distribution follows what kind of distribution this image follows, guys? Right? Tell me what kind of distribution this data follows. Just imagine. So it is in the same link in the YouTube channel that I've actually given. What kind of distribution this follows? This follows a Pareto distribution, a power law distribution, right? So we can basically use a box cost transformation to convert this data, right? So if you go through this, you're well covered with respect to everything. Okay. So I think I was able to cover up most of the things in this 7 days session. I hope you like this session. Okay. And I hope you learn a lot now. Now it's time for you just to think more ahead, solve multiple use cases, and do some amazing work. Okay. So this was the 7 days. How do you like to rate it? And from Monday, I'm probably going to start. I'm probably going to start machine learning algorithms. Tomorrow, I'll take a rest, and on Monday, I will announce it. Okay. One thing I missed: central limit theorem. Okay, I'll discuss about central limit theorem. Okay, central limit theorem. So central limit theorem basically says that if I have a distribution that is either normal, that is not normal, or that is any kind of distribution that I have, okay, whenever we basically take up multiple samples, let's say that I have this distribution or this distribution or this distribution. If I take up some multiple samples, let's say that n is greater than or equal to 30. If I start taking multiple samples from this particular data, let's say that I have taken multiple samples like this. like this up to n is greater than or equal to 30, like many samples. Okay, and for every sample, if I start finding the mean, okay, mean, if I start finding the mean like this up till xfm. Why I'm saying n should be greater than or equal to 30? Because the more greater than or equal to 30, the more the central limit theorem holds. Okay, so if I take this entire data of this sample mean, all this sample mean, and if I populate it in the form of pdf, then that basically says that it will get converted into a normal distribution. So this will basically be a normal distribution. All the sample mean will follow, this sample mean will follow a normal distribution. Okay, sample mean will follow a normal distribution. Yes. So here you can see that whatever distribution it may be, if we take some samples, specifically n is greater than or equal to 30, for each and every sample, if I try to find out the sample mean, okay, okay, sample size. So see, sample size, I told you it should be n is greater than or equal to 30. Sample size, the number of elements over here that we are picking should be greater than or equal to 30. And let's consider that we have taken m samples. Okay, m samples can be anything. Okay, but more the bigger value, more better we will be able to solve this particular central limit theorem. Okay, so here you will be able to see that as we go on doing this, finally you will be able to see that if we populate all the sample mean, we get this normal distribution. Initially, whatever distribution that particular data may be, it may be a log normal, it may be normal, it may be anything. Okay, is it clear everybody with respect to this? Everybody clear? Yes. Now one assignment for you all will be Poisson distribution. Now you have got a lot of idea about data now. Okay, you just go and search in Wikipedia, see the distribution shape. This is also a non-Gaussian distribution. Okay, it also follows the Pareto distribution. You can see in this way. Just go and check it out. That's it. Okay, so overall I hope you like this 7 days of stat session. I know I'm running a company, but I would definitely like to give it to the community all the time. In the upcoming classes, we'll be having machine learning algorithms, 7 days live session. Okay. Then we will be having deep learning algorithms. Okay. Then probably we can take up Flask 7 day session and Django 7 day session. Right. If you want MongoDB, SQL, that all things I'll try to plan, because this year I'm planning to only take a live session. Okay. So all this kind of things we will be doing, probably a series of blockchain session of 7 days, where I'll probably show you how to create your own blockchain and all, everything. So like this, we will try to plan it 7 days so that the full week I'll be occupied and I'll not get 1 minute also to breathe. Okay. Just kidding. I get a lot of time to breathe. So all these things we will try to do. Tomorrow, I'll take some rest and probably announce this. Every day, 2 algorithms we'll try to complete. Okay. By this way, we will be able to complete all the machine learning algorithms. Okay. So I hope you liked it. Again, for supporting us, please join One Neuron platform. Help us in innovating the tech world with the affordability and with the quality that we can provide. I know we cannot satisfy each and every person. Okay. There will be some people, if we don't reply, if we are 1 minute late, they will kill us. Okay. So it happens, but no problem. Patience is virtue, we say. Okay. So this kind of sessions we will do. Okay. And yeah, please make sure that you subscribe Krishna Vlogs channel. There also I have started putting Hindi videos in machine learning. Okay. So please do that. Don't forget it. And yes, how was the overall session? Just rate it, whatever rating you want to give me. I will never say nothing. Okay. I never say anything to my students. Okay. So now it's come, like, how was the entire session? It was good, right? Okay, perfect. Ajay Chaudhary, I use Scribble Ink. Scribble Ink is the tool name. You can see over here, Scribble Ink. Okay. So, okay, guys, this was it from my side. And yes, tomorrow announcement will be done with respect to machine learning. I hope everybody joins, and yes, to hit the like button. This was it from my side. Have a great day ahead. Thank you, one doll. Bye bye. Keep on rocking. Keep on learning. See you in machine learning live sessions. Bye bye. Thank you, guys. All the materials will be provided. Don't worry. I will upload everything that I have with me. Okay. Thank you, guys. Bye bye.